Hey there, guys. This is Mr. Herbst here, and welcome to Chapter 4. Chapter 4 is all over machines and mechanical systems. And we're going to go ahead and start with Chapter 4.1, which is all over forces in machines. Now imagine a world without machines. Imagine if your job was to drag home your dinner over to your little colony or society. Well, you killed a big elephant, and the best thing you know how to do is just drag it home with a rope. And that's pretty hard to do. That's a very, very exhausting thing. So the world without machines is a very, very hard place. Now, thankfully, we have machines in this world where the most simple machine that we have used to carry large objects home over long distances was the wheelbarrow. Um, so imagine how much easier it is to carry things over long distances using a wheelbarrow. Also, over the course of several hundred years or so, we have developed machines within machines, such as locomotives and cars, where actually we have all of these machines working together to perform a very complex task. And we'll talk about that in a second. Also, we have developed the use of computers, which are machines within themselves, which are all based on the original computer called the abacus, which was a very, very simple computing device. But, over thousands of years, as humans got smarter and more intelligent, we were capable of building more and more complex machines. So, simply put, a machine is a device that changes the force you used on it. So it's a piece of technology that's designed to do something useful. And when you have many simple machines working together to perform a very complex task, what you have is a mechanical system. So one of the easiest examples of a mechanical system that I can describe to you guys is imagine an assembly line building cars, dozens of cars a day. You got here one of those arm robots that does all the painting and all the screwing and does all the things for the car. That is a very complex mechanical system that's working on very many different types of machines all rolled into one. And another good example of a mechanical system is, boom, your cell phone. Your cell phone is capable of performing very complex tasks, and it does that using very, very actual simple types of machines. So how does a machine work? Well, it works by changing the size and the direction of forces that you put into it. There are two types of forces that we talk about when we are talking about simple machines. One of those is the input force. The input force is how much you give into the machine, how much you exert into the machine. And the output force is how much the machine gives off based on what you put into it. So a good machine, something that will make your life easier, is a machine that you have to do a very small exertion into it, but it gives you a very, very big result based on your input force. One of the best examples that I can think of to describe machines is simply a set of pliers. If you know over here, when you squeeze a set of pliers, it's not very hard. But if you ever stuck your finger in a set of pliers, you'll know that the force that's exerted onto you from the machine, from the squeezing of the levers on the machine, can be pretty substantial. In fact, it's capable of actually breaking fingers. Now, it's not possible for me to clamp down on somebody's fingers and actually break them, but a pliers strapped onto somebody's fingers and then squeezed actually could do some serious damage. So what you get out of it is a higher output force than what you put into it. The squeezing is the input force. The pliers, which are clamping down on the object that you're clamping down on, is the output force. So that was an example of a type of machine, a simple machine that we call a lever. There are other types of levers where we have, for example, you could have a type of lever like this, where say your job is to move a really heavy boulder. Well, what you could do is stick a smaller rock next to it and stick a long pole underneath and wedge it underneath of that bigger rock and push down, and you have to put in a small input force, but your output force is going to be great. Another example is, like I said, the wheelbarrow. You can lift up a heavy amount of soil or grass or whatever's in the wheelbarrow just based on a small input force that you give into the wheelbarrow. And then also your arm, although it's not a very useful lever, it is a type of lever. Your bicep right here. Your bicep is actually attached to your forearm, and when your bicep contracts, it actually pulls in on your forearm. Now, we're going to talk about this later on, but the actual advantage that your arm gives, the mechanical advantage, is actually very small. But the reason that your arm is useful at lifting objects is because your bicep only has to contract a very, very small amount, but it actually allows your hand or whatever's in your hand to move a very large distance. So it's actually really useful. Another type of simple machine that you guys should be getting down in your notes is an inclined plane. Now, why are inclined planes useful? Well, imagine that your job was to lift up a bunch of objects into a truck that was several feet high. It would be relatively hard to do some deadlifting and just pull and push onto the truck. What we use is an inclined plane where you increase that distance, but you walk up it slowly, and it makes your job easier to put things into that truck. Another type of simple machine is the block and tackle, which you probably have commonly been referred to as a pulley. Pulleys allow us to change the direction of force that we're applying, and also we can add more pulleys inside of pulleys to give us a really high mechanical advantage. For example, it is capable for a human being to lift a 2-ton object, a super heavy object, with very, very minimal input force if the block and tackle gives us a very, very high mechanical advantage. And we do that by looping things around over and over and over. And we'll go into that in lab. Another type of block and tackle, though, that you guys have probably seen pretty frequently is a crane. A crane is a set of pulleys that allows very heavy objects to be lifted up with very minimal work from that machine. The last type of simple machine that you guys are going to be focusing on in this class is gears. Gears allow us to change forces and also change speeds of the way that we want things to spin. So for example, if we got this gear right here spinning very, very fast, we could make this gear really, really large, and as a result, this gear right here would actually spin slower. So what we can do is we can change forces and change speeds on things that we want to spin. Now, here's the really, really important thing to understand about machines is that all of them give us what we call a mechanical advantage, or at least machines that we use on a daily basis to make our lives easier give us a mechanical advantage. Simply put, a mechanical advantage is how much a machine multiplies your input force. So, like I said, if you put a small input force into a machine, you want to get a big output force, which will make your life easier. So mechanical advantage is just a ratio of output force to input force. In order to calculate that, we have actually a very simple formula where MA, which stands for mechanical force, or mechanical advantage, will give us which is calculated by dividing the output force divided by the input force. So let's say that our output force is 5 and our input force is 1. Well, in that case, our mechanical advantage would be 5. And now you're wondering, based on this class, you probably are wondering, what's the units? Well, there actually is no units. When we talk about ratios, there are no units of ratios. It's simply just a ratio of our output force to our input force. The bigger the number, the bigger the mechanical advantage, the easier that machine makes you. Anyway, here, guys, that concludes simple machines and forces within machines. I'm Mr. Herbst here, and I'm signing off. You all have a nice day.